Let's take a few minutes and derive double angle formulas from the addition formulas for sine and cosine. Notice that if we have sine of twice an angle, and I'll just use your textbook's notation, sine of twice the angle u would be sine of the angle u plus itself, which in the sine addition formula for sine is sine of u times cosine of u plus cosine of u, sine of u. Multiplication is commutative, so these two terms are identical, and they collect to give us 2 sine of u cosine of u. I like to read this as sine of twice an angle is twice sine of the angle times cosine of the angle. Okay, and that's the first formula you see in the list from your ebook. Okay, the second formula, cosine of twice an angle, is cosine of the angle plus itself. So that's cosine of the angle times cosine of the second angle. Change the middle. Sine of the first angle, sine of the second angle. So we end up with cosine u minus sine u, which collects as cosine squared u minus sine squared u. Okay, now these are your primary go-to formulas. You can notice that you can produce 2 more versions of cosine 2u using the identity that we developed earlier, the Pythagorean identity. Sine squared plus cosine squared equals 1. We can use this as cosine squared u is 1 minus sine squared u, or sine squared u is 1 minus cosine squared u, and making those substitutions leads you to the 2 alternate versions of the cosine double angle formula. Now, the tangent formula, you simply could do tangent. If you already know how to calculate sine and cosine, you could leave it at that. You could say, okay, I've got a formula for sine 2u, and I have a formula for cosine 2u, and tangent is sine of the angle divided by cosine of the angle. If you take a few moments and spend the time to put the formulas in for each, then clean it up, you'll get this bottom guy here. Okay, I don't know that it's particularly necessary for you to memorize the third formula, but you may if you wish. Okay, because you can get at what you need using this guy.